Big lack of men on campus. In 2007, 135 women received bachelor's degrees for every 100 men. According to the U.S. Department of Education, that gender imbalance will widen in the coming years, as shown by the bar graph. Before we look at the bar graph, let's look at the formulas given. M represents the percentage of bachelor's degrees awarded to men, and it's given by negative 0.28 n plus 47. Whereas W represents the percentage of bachelor's degrees awarded to women, and it's given by 0.28 n plus 53. And it's important to note in our formula that n represents the number of years after 1989. So the bar graph shows the percentage of bachelor's degrees awarded to United States men and women. And we have three time periods shown, 1989, 2003, and 2014. Let's go to Part A. According to the first formula, what percentage of bachelor's degrees were awarded to men in 2003? Does this underestimate or overestimate the actual percentage shown by the bar graph? By how much? Well, the first formula shows the percentage of degrees awarded to men, and we're looking in 2003. Well, we need to take 2003 and subtract 1989, because it's that many years after 1989. We'll get a total of 14 years later. So we'll substitute 14 in for n. So m equals negative 0.28 times n, which is 14 in this case, plus 47. If we calculate this amount, we'll get a total of 43.08. Well, the question is, does this underestimate or overestimate the actual percentage shown by the bar graph? Let's take a look at the bar graph one more time. The bar graph shows in 2003, men is represented by the blue bar, that exactly 43% of degrees were awarded to men. In our answer, we got 43.08%. So we have just a slight overestimate. And by how much? Well, 43.08 minus 43 is just 0.08% of an overestimate. Let's move on to Part B. In Part B, we want to use the given formulas to write a new formula with a rational expression that models the ratio of the percentage of bachelor's degrees received by men to the percentage received by women n years after 1989. Name this mathematical model R for ratio. It's important whenever we write a ratio to write in the numerator the first item given. In this case, we want the ratio of the percentage of bachelor's degrees received by men to be up in the numerator. Well, that ratio is given by negative 0.28 n plus 47 in the numerator, that represents the percentage for men, divided by or to the percentage received by women. The formula for women was 0.28 n plus 53. So we can use this ratio to determine the percentage of bachelor's degrees received by men to the percentage of bachelor's degrees received by women. Now, in Part C, we want to use that formula R to find the projected ratio of bachelor's degrees received by men to degrees received by women in 2014. According to the model, how many women will receive bachelor's degrees for every 2 men in 2014? And how well does this describe the projections shown by the graph? Well, first, let's just rewrite the ratio that we just wrote in Part B. R equals negative 0.28 n plus 47 divided by 0.28 n plus 53. Well, we're looking at the year 2014 in this case. If we subtract 1989 from that, we'll get a total of 25 years later. So in this case, n is equal to 25. So we'll substitute in 25 for n. And we'll calculate this ratio. We substitute 25 in again. When we calculate this ratio, we can use a calculator, and we come out with a total of 0. repeating 6. If you recall, 0. repeating 6 can be approximated by the fraction 2/3. So now, we've just answered the first part of Part C. So how many women will receive bachelor's degrees for every 2 men in 2014? Well, it says here our ratio is 2 to 3, so the ratio of 2/3 represents 2 men for every 3 women receiving a bachelor's degree. So, how well does this describe the projections shown by the graph? Well, let's look one more time at the graph. So in the year 2014, the bar graph shows that for 40% of men receiving a bachelor's degree, 60% of the women receive a bachelor's degree. So let's compare that. The graph shows 40% men for every 60% women. Well, if we reduce this, it reduces to 4/6, which is the same as 2/3. Well, how well does this describe the projections? It's exactly the same. We got 2/3 by our ratio and 2/3 by our graph, so it's exact.